All right, last one here on resistance and thermal systems. So big one, but really short PowerPoint on this one, okay? Why is that? Because there's not a lot of systems to talk about with resistance and thermal systems. It is what it is, and that's what all we got. So let's go ahead and move on. So resistance and thermal systems. Thermal resistance. Oh, and you cannot see that. Let me adjust that for you. There we go. Oh, no. Let's get that. There we go. Okay, so thermal resistance is a measure of an object's ability to oppose heat transfer. Thermal resistance is the ratio of the temperature drop to the heat flow rate, or R thermal is equal to temperature drop divided by heat flow rate. Okay, so Q is at heat flow rate. Thermal resistance in series. So walls are often constructed with layers of materials of different thicknesses and different thermal conductivity. Insulation is a substance with high thermal resistance. So if you were to make your walls out of paper instead of wood, you'd have less thermal resistance. So you'd have more heat or cold coming in. Just like if you slept in a tent versus in your house, even without insulation, you're going to be warmer or cooler in your house because it's going to conduct the heat transfer differently versus a tent, which is going to really fluctuate with what the outside ambient temperature is. And that's why we add the insulation as well. A devoir is an insulated container for holding extremely cold materials such as liquid nitrogen. So if you know what liquid nitrogen is, it's that really cool stuff that comes out of, it's really cold, and so to keep it cold, you have to make it into liquid nitrogen, because nitrogen is typically a gas. You make it really cold, it turns into a liquid, and then you have to keep it really cold, so you use a devoir. It's provided by the insulation provided in that container is by a vacuum to prevent conduction or convection. It does not prevent radiation. So that container is still going to feel a little cold, and you let that heat coming from the outside also going to get through to make that gas warm up a little bit. That's why you start to see the gas, the flow looks like smoke more or less, but it's that liquid nitrogen is actually radiating and starting to be turned back into a gas through evaporation. So here we go. Look at this. Here we have two examples. The home insulation. This guy's using a higher value insulation. He's stuffing into the walls, and you can see it in the roof as well. So you just push it in the walls in between the 2x4s or 2x6s, 2x8s, whatever you actually use for your studs in a house, and in your roof. And you can even, if you're living in a second story, you can have it in between the stories as well. So you just push it in there, and it actually causes a barrier for the heat to actually dissipate into instead of getting into your house. Put the walls up on both sides, gives another barrier, just creating a small gap in between the outside world and the ambient temperature changes, and your inside, which you try to keep at a very similar temperature. That devoir there has a vacuum when you're using it. It actually has a vacuum in between and causes that gap to where you can actually have less change in temperature on what's inside. So here's 4 questions. Told you this one was short. Take a pause, answer the questions, and good luck. All right, welcome back. Here's your answer key. What's the first question? What is the formula to calculate thermal resistance? R thermal is equal to the temperature change divided by the rate of, let's get that answer back again, heat flow rate. Okay. Insulation is the answer to what is the substance with high thermal resistance called? Insulations or insulators. What container is used to contain extremely cold substances called? Devoir. Oh, I misspelled it here. That's okay. Just change that out. Container in question 3 eliminates all types of energy transfer except what? Radiation. And I'll just edit that for you guys real quick so you can see it. You're going to see me do it right now. I don't want to spell that wrong. All right, there we go. Good luck on this one, and remember to have fun.